In yesterday's video, I talked about today's enhanced risk setup a little bit, looking at our tornado risk for regions down here in the south. Since then, that risk area has expanded quite a bit. Not extremely, but we have expanded into more states here. Arkansas will be impacted more so, Georgia, bits of North Carolina now, and more of Kentucky, as well as little bits of southern Illinois and Indiana. But because I talked about that risk so much, I wanted to talk about the main update that I saw that happened, which was Illinois has been expanded into a higher risk area. So if we can see, here's our level 2 out of 5 slight risk we have in play for Illinois today. This will be all hazards at play. Here's our tornado risk for today. 5% contour, pretty well into Illinois here. Kind of the central part of the state. Not so much with the northern extent. Wind isn't the main threat also, but it is there. But hail and tornadoes, again, being the main threat. That's kind of been the main idea for the past few days. So I wanted to look at this threat and just kind of explain what's going on, look more into the meteorology again, because I did talk about this video yesterday, so if you want more information, go to that, but I wanted to go more in depth into specifically our Illinois threat. Looking at our jet stream here, we're at 250 millibars. This is our 9Z initialization, so that's going to be 4 a.m. Central Time. That's when we're looking at what was the weather at that point. I'm looking at the WRAP model right now. I really love the WRAP, and this is the earliest run I can get of it. So looking at 250, we can see a pretty large troughing feature here. This has a negative tilt. We can see this pretty apparent right here. Also, we have this jet streak rounding the base, which is often good for helping storms get lifted up into the atmosphere. Let's move forward with time here, so you can kind of see how this trough will eject. This jet streak slowly overspreads the region of Illinois, getting a little bit of some speed maximum, especially as we get later on today. That's 4 p.m. Central Time there. This will assist in again, lifting motion. If I zoom into Illinois here, let's look at our streamlines and see if looking for divergence. Divergence is not extremely impressive, but it is here. We can see some of our streamlines here are a little more out of the southwest. Others take more of a western, or sorry, directly north or southerly approach. Excuse me. So we can see again, we have this area of minor, but it is their divergence or diffluence here. Wind vectors are spreading apart, which will help lifting motion. Again, I've talked about this before. We can imagine if you have different winds moving in different directions, the atmosphere wants to fill in the gap, and it's going to bring up air from below. That wasn't the best drawing of it, but the idea remains the same. Let's go back into the United States here again. We'll go to 500 millibars. It should be a very similar story here. Again, even this morning, we have a little bit of a jet streak. And one thing I wanted to mention here is some of our early morning storms. So looking at Illinois, we do have some cloud cover going on. For the most part, a lot of Illinois is seeing some cloud cover at the moment, but you can see this clearing out behind. And while a lot of this coverage is more on the near the surface, which could be an inhibitor, I'm a little bit confident because of this clear slot out behind. You can very clearly see our cyclone here. I can move this with time here. This is the base of our cyclone. You can just see the rotation. You can see the winds out of the north here and some more out of the south, very clearly showing our low pressure system, basically based in Missouri. The model should continue with that. I'll look at that in a moment. But again, jet streak will be rounding the base as we talked about. Divergence is actually quite easily seen right here at 500 millibars. You can see some of her winds are moving out of the southeast, and some of them are other ones are moving out of the southwest. So again, general area of divergence. You can see a little behind the scenes there. Vorticity, again, definitely maximized. We do have a surface low occluding, and I'll look at that in a moment. Temperature's a big thing, though. I looked at this briefly yesterday because I thought it was kind of interesting, but this has remained on our models. This little area of kind of colder air. You can see these colder temperatures here. Negative 18 degrees Celsius. It is May, so it's definitely warmed up quite a bit, but this will help steepen a lot of lapse rates of aloft. When you have this colder air, you can imagine that your air from the surface will be more buoyant and stay warmer than it for longer. 700 millibars, I looked at this yesterday as well. We saw this lead shortwave, and that definitely is it's almost certainly what is causing all this cloud cover right now. We do have a lot of precipitation as well. Radar scan, we saw a lot more this morning, although it looks like it's cleared out a little bit, which is a good thing. Possibly another shortwave here, actually. Pretty well, kind of well defined right here. You can see the kinks in the contour lines. That's not a very impressive kink, although it was there basically a frame before here. But definitely a few little kinks on the contours. Seeing right here especially, we have winds here, indicating that kind of little boundary here with a little bit of a shortwave in there. that could help in storm development later on. Very well defined here, just the kinks in the contours. That's very interesting to me. That could assist in storm development later on in the day. 850 millibars, again, moisture is in place here. Maybe a little bit of issues with it a little bit, but for the most part, we do have good 850 millibar moisture. That's your low levels. Looking at our wind speed, a little bit lacking, admittedly. These aren't going to be big time storms if they are going to be firing. Again, this is a conditional setup. I do want to mention that the setup is very conditional, and things could go right and could go wrong. But I'm looking at what could go right as of now. 850 millibars. You can certainly see this warm sector, pretty impressive. Moisture again, pretty prevalent in that warm sector as well. Unstable air mass, looking at theta E. So again, this is a good area for storm development. Some of the parameters are in place. The main issue is going to be our surface conditions. We have good moisture in place. Here's our mixed dew point, which essentially is just a little more like accurate how much depth you have. But for the most part, we have pretty good moisture along much of this area here. Again, you can pretty clearly see where our warm front is located here, where that moisture kind of drops off, and especially also that cold front. Let me get surface temperatures, actually. Yeah, I can see that warm front pretty clearly. This scenario looks like our low is not really occluded as much as we expected. I would expect a little bit of an occluded front somewhere in this vicinity here. But a cold front is probably kind of draping down. Yeah, not super impressive cold front, actually, which is probably helpful for storms. It'll help them stay more discreet. There's not really a good place to place this cold front, but for the most part, if I were to do surface analysis here, I would place our low pressure system out here. You can see the winds, the rotations there. I'd actually place an occluded front right here, and an accompanied warm front here, and cold front down here. Because this area is the open warm sector, good moisture in there. But also you can get warm frontal storms in these more cold cores type setups, because we do have that colder temperatures aloft, overspreading a lot of the warm front as well. That could really help for any severe threats today. And before I get to any soundings, I want to look at our instability. Here is our surface base, Cape and Sin. Same thing here. This is our mean layer, Cape and Sin, with storm motion underneath it. You can see that storm motion is not very impressive, which could be helpful for any storm chasing, or just to be more aware and be able to see a storm for longer before it hits you. Instability is not super impressive, but we are above that 1,000 joules per kilogram threshold. Some locations might reach up to 1,500. Surface base Cape is a little more bullish than the mean layer Cape was, but in all scenarios here, we do have a good amount of instability to work with, and we have this low level instability. Here's our 3 Cape, and this is something important here. These greens indicate 100 joules per kilogram. When our main forcing is not as intense, we have to kind of rely on low-level circulations being stretched vertically. Having this 3 Cape is very helpful. Going forward one frame here, you can see very quickly a lot of low-level instability and peaks there around 21Z, which is going to be 4 p.m. Central Time. But this low-level instability remains even for a while, even into the nighttime hours here in Indiana, possibly even remaining into tomorrow for another accompanied tornado threat out in there. I wouldn't be surprised if storms do develop today, that we see it's called a mesoscale convective vortex, and that happens when we get storm development. I wouldn't be surprised to see redevelopment out here because of that. So I would keep an eye out if you are more east here, but definitely for today, excuse me, I will be paying attention to this low level instability. That's probably the main good thing for this setup. Low level lapse rates are also decent. Could be a little bit better though. I'm pretty sure this is the cold front out here. Mid-level lapse rates should be a little bit better. Interesting. I do remember seeing this earlier, so this might have changed a little bit. 18Z, though, we do some better mid-level lapse rates as well. So let's finally take some soundings, because I know that's what I like to do. Let's take one on the warm front here. And I'll take one on the cold front, just going to see what our initial conditions look like. Rid of this. I'm looking at our map again. This is going to be our warm frontal storm. Again, you can see this instability pretty far off that CUT. Possibly still some capping in place. But you can see a lot more looping in photograph here. More out of the east here too. So I might have taken this a little bit too far north. Near that cold front, a similar story. Lots of instability. It's more confined to our lower levels of the atmosphere. Again, lots of instability, a little bit bullish, but we definitely do have that instability in place. Photograph is certainly one to be desired for, but these straight photographs could lead to storms splitting early on in their life cycle. Let's move forward 3 frames here. Again, the one thing to note is our wind vectors at the surface might be a little bit of an issue for today. We don't have strong southerlies or anything like that. Kind of more of the southwest, and that does inhibit some of the inflow. If you imagine a storm having inflow like that. But either way, this could be a setup just regarding like stretching the level for vorticity into the vertical. Here's the level vorticity by the colors. Excuse me. The colorful parts here, that's your vorticity. And the contours are your 3 cape. Right here in this bullseye, you can see a good amount of low level vorticity and 3 cape in the same location up here in northern Illinois later on. Again, instability here. But this wind vectors not being out of the south is a little bit of an inhibitor. Let's move more north. And also, I'm going to be taking, let's go to the NAM, because I'm also curious what the NAM is looking like. I should look at NAM Nest. Ooh, no, I'm not looking at the NAM Nest. NAM seems to be a little more extreme with its instability and its moisture here. Again, here's our instability, a little more impressive there out of the NAM. Here is our wrap sounding. Again, a little more looping here, more out of the south, which is better for tornadoes. 3 cape is kind of ridiculous here, 246 joules per kilogram there. But yeah, you can see our storm motion a little bit goofy for the most part. So we could end up with some, not sheared out storms, just storms aren't really able to get going. So that might be an issue with this setup, especially with this more elongated cape in this UT here. But I am more confident in this low level instability to be able to stretch upwards. Let's take a NAM sounding here. And lastly, also reflectivity. I haven't looked at that yet. Oh, 12Z is perfectly out, just fresh. How perfect. And here's our 12Z initialization from the HRRR. You see some of the early morning showers, then behind probably some of our more significant storms here. These could have some couplets though, from what I can tell. Here's our NAM sounding, looks a lot better. Photograph still a little to be wanted. 3K at 260 joules per kilogram, and our instability as a whole is just more impressive here. Maybe a little, I wouldn't really call it inverted. That's a good height for LCL there for cloud heights. Instability definitely there. So cloud height should be pretty low, and that will help get storms get firing with bubbly cumulus. The HRRR run has a lot of storm coverage, especially in the earlier days or parts of the day. The more coverage later on. Let's see if any of these are rotating with updraft helicity. Looks like a few cells could be rotating, and that's the main thing I'll be looking out for is which cells will be looking good. Could have couplets like that. And then NAM Nest, not again. Updraft helicity there. So let's look at reflectivity first. There's also 60, so this very well could change very soon. We're seeing a lot, again, more storm coverage, especially more on 20Z. Well, that's going to be 3 p.m. Kind of after lunchtime there, really storm development. And a good amount of storms along the warm sector there. Even a little bit of Boeing line segment afterwards, actually, which is interesting. I take a sounding in the middle of those, why not? And again, you didn't see a very impressive updraft helicity out of this. One more thing I want to check, because now I am curious, is going to be the high-res ensemble forecast. This is often really helpful for understanding how the CAMs, the convective allowing models, are agreeing. So I'm going to go to the Midwest sector. This is 0Z, so we'll keep that in mind. One second, here's our NAM sounding. Again, same thing we've been seeing in all of them. We want more southerly winds, but we have that low level of instability and possibly more instability to help to accompany for the lack of good winds out of the south or southeast. Here is our probabilities of updraft helicity. You do see we get this maximum here, kind of in the evening hours in central Illinois, and this was yesterday. So this means the models have been kind of confident of this for a little while here. This was yesterday's runs, and again, you can see that we do get this little 10% probability contour basically right after lunchtime there, into the early evening, and then into nighttime afterwards. You can see here 30% isn't, it's not really impressive, but it definitely means that risk is there. So we could have this possibility of some, discrete little, probably low-top supercells, but they could be forming anything underneath them. And some of this instability, considering that most of the instability is kind of in this layer here, where hail growth zone is, you can see where we have those two blue lines. This is your freezing line here, and this is your other line. So this is an area where you get super cooled water. That is when water is colder than freezing. It should be frozen, but it's too small to actually freeze. That's a really good spot for hail to grow in. A lot of our instability is confined to that region. and that will aid in probably seeing some hail out of these storms. Nothing incredibly significant. I would be surprised if we see anything significant. HRRR has this new way of showing again. A few of these storms could be producing some hail. Nothing, no big time hail out of these. Doesn't look like that. So that's gonna be it for this video. Again, if you are in this area, do keep an eye out on the weather because things could get interesting. If storm coverage looks a lot better, or maybe cloud cover decreases faster, we could end up with more significant severe weather today. So I will be keeping an eye out for that just in case, because again, you can never really tell with these setups. Sometimes they end up being very conditional, so they could fire, they could not, and SPC might limit from going with a higher risk. I wouldn't expect a higher risk out in here really. 5% seems very good because it shows that conditional risk, but also there is that possibility. So that's me it for this video. Again, if you've enjoyed or have any comments, questions, please let me know. Otherwise, thank you for watching, and I'll see you all next time.